So what I'm going to present today is a data infrastructure building block out of NSF. It's a call basically to build components that would make up a data infrastructure for the scientific community to support their various data needs these days. Most scientific domains, if not all of them these days, require some aspect of digital data and digital software. So supporting that, preserving that, making the science still reproducible is a big concern of the NSF. And so DIBBs does that, builds these components out, and Brown Dog is one of those things. And so basically what it is it's Brown Dog is a data transformation service for the scientific community. And I'll explain how that fits in with things in a moment. But in essence, what its job is to do is basically to kind of simplify and make more reproducible what I term often as the data wrangling step that scientists often do. And so when starting on a new project, as I mentioned before, we're part of a software group here at NCSA that supports scientific efforts in the community. One of the things we often do at the very first stage is, if not throughout the entire project, is this data wrangling step where we're basically finding data collections, bringing them where do we need them to be, converting them to the formats we need them to be in, extracting subsets of the data that we're interested in. We don't want the whole thing, for example, or cleaning the data, filling in gaps or other kinds of things in the data so that we can do what we're actually interested in the scientific effort of the project. And so basically what Brown Dog is aiming to do is kind of really simplify the ad hoc steps that often occur in these things. People bring together code from all over the place. You got to find the code to convert X. You got to find a code to pull out this part. You got to try to run that code if you can't find the documentation, don't have the platform, and so forth. Or write the code yourself if it doesn't exist. And so trying to basically eliminate as much of that as possible so that in terms of the scientific workflow, you can kind of start right after that with what you're interested in with the science. So just getting into that word a little more. So data wrangling. So we start at the upper left here where basically we have our collections somewhere out there in the web or maybe on somebody's hard drive on somebody's shelf somewhere. And so let's assume they're online for the moment. And so there's URLs and file systems or, even some data sets we deal with aren't even digitized. They're paper documents, one of those for ecologies, forest inventories from centuries ago. They would like the numerical data that's in that because it basically gives a way of validating the models far older than any digital data source they have otherwise. And so you have your data collections out there, and so basically you want to get those. And so the way the data is stored, assuming it's digital again, is in a variety of different means. So you're dealing with a bunch of different file formats. They could be commercial file formats where the proprietary. You don't have access to the software or the specification to access the bytes directly, so you need some special software to get at the contents. They could be old formats where basically there is no software easily accessible to get that data. They could be made-up file formats. This happens all the time in science. People just make up their own file format. Micro formats. This is what we refer to as when you embed kind of a schema within another format. Spreadsheets is a great example of that. The rows and columns mean something. You don't document that anywhere. So they refer to those as micro formats and so forth. So this is kind of where we start. So you have your collection and you have these representations. And so the first step, the first transformation Brown Dog supports is what is we refer to and anybody refers to as conversions. So basically you convert that to some format where you can then get access to what you want inside the file. If it's an image, the pixels. If it's a depth map, LiDAR data, the depth values, and so forth. So the raw contents, the numerical values, the raster image, and so forth. And just for the sake of clarity, because we support two main types of transformations here, we just define specifically what a conversion is to distinguish it from another one. Basically, it's a transformation that largely preserves the entirety of the data. You can potentially go back and forth. It's a one-to-one mapping. In reality, that's not the case. You often result in information loss in these tools. But ideally, if that doesn't occur, it's a one-to-one mapping. And so the second step often involved with this data wrangling, once you have access to the contents, it's not really the starting point yet. You want to do something to that data. You want to extract a subset of it. You want in the LiDAR, for example, in the hydrology world, you might have a LiDAR data and you only want the river locations. You might want to find a specific tree or a forest or do something with specific trees and so forth. You don't want the entire thing. And so we refer to this next kind of transformation as one that takes that data and does something to get the data that you want. We refer to these as extractions, where basically we're taking the original data and basically churning it up, turning it into a hamburger and spreading out some derived product. This could take the form of something like metadata that it's useful in terms of basically searching through a large collection of data. Tag this piece of LiDAR data with having a river in it, or this location is having a river in it, and so forth. Tags like that, so you can then query a large collection and find the stuff you want. Other derived products such as visualizations, maybe something convenient to preview the data on the web, a thumbnail, stuff like that. Cleaned versions of the data sets, things without holes in it, and so forth. And so all kinds of derived products that come out of this kind of transformations. And so this is the second type of transformation that Brown Dog supports, all towards getting to where we want to be, some sort of scientific application which can take it from here to do analysis, further analysis on the data and so forth. And so the idea here is as we move from left to right, we're moving towards more usable data for the scientist versus the raw data in the beginning. So just as kind of a visualization of this. So you have some data, so some files, some data set comes in. All right, that's what you got. Step one is you go through this transformation of a conversion so you can get it to something you can see. So in this case, it was an image with one of my colleagues in front of a plaque in front of some trees. And so the conversion allows you to see the data and get the pixels. And then the next step is an extraction. So as an example of that is we basically spit out anything we can extract from this data. And this is we do this in Brown Dog as JSON. So this is basically a JavaScript array. Lots of web technologies utilize this as a convenient way of spitting out data and utilizing it with other applications. It's pretty simple for a human to kind of look through also. And so in this example here, what's spitting out is usual metadata like the location and the geotags and so forth of the image. Other things like OCR extraction, pulling out the text of that plaque in the background, finding there's a face in the background, tagging it as such. And then some more scientifically relevant ones, like for one of our use cases in civil engineering, things like the green index, how much foliage is in that background. So it has a numerical value for that. A model of human preference score for green infrastructure landscape design is also in there as well, basically annotating that. And so the idea is all that information, there's a suite of transformations that Brown Dog will support. It would basically spit out all the information it can for this specific data type and provide that to the user or the application that uses Brown Dog to do whatever they want with it. And so what kind of data do we need to deal with? So in the scientific community, it's very diverse. All kinds of different data. So for the past decade or so, working with the scientific community, these are just some of the things we've dealt with. There's all kinds of data from image data, satellite data, radar data, video data, all kinds of different things, and all kinds of different steps that we do on it, such as, for example, land coverage, identifying a piece of satellite image that has urban landscape or a forest or water, things like that. Extracting rivers from an old historical map, so that you can overlay it on a modern day location, because those things change over time. Hyperspectral data, color corrections, all kinds of different stuff. So the idea here is it's diverse. Lots of different kinds of data sources in the scientific community. And this is actually where Brown Dog gets its name, is the idea is there's lots of tools out there. And so first of all, we're not in the business of trying to reinvent the tools that exist already. The idea is to kind of bring them all together in this consistent, coherent service. And so basically wrangling all those tools and also different kinds of tools, whether it be scripts, different kinds of languages, running on different platforms, different services, open source, closed source, GUI-driven applications, doesn't matter. If they open some file and save it in a different format or spit out some content that's useful for a scientist to sift through some data, we want to use it. And so that's basically where it comes from. The name Brown Dog is a MUD of different software. And so basically the idea of supporting all those different kinds of technologies in one consistent framework that's easily leverageable and preservable for the community is what we're after here. So Brown Dog, the main key factor here, again, because of all the different kinds of data within the scientific world, is extensibility. That aspect, again, different kinds of software, being able to change over time. So those tools, sources used, scientists are always pushing the forefront. It's never going to stop. It's always going to change. And so being able to easily add new transformations, converters, extractors to the system is key. Being able to support whatever platforms are out there to run these tools and extractions on is key. And so basically this piece of cyber infrastructure we're building here is built around this idea of basically running anything potentially as part of the service. And so that's one of the key elements of this. And also encapsulating that software in a manner that's more preservable. So we used to use virtual machines. Now we've switched over to Docker. Docker used to be only Linux, and now it's supporting Windows as well. And so basically it's a convenient way of encapsulating not just the tool, but also the environment around the tool to be able to run it in the future as well, and grow it in our system as well elastically, which I'll maybe highlight later on. The second aspect is an API. And so the idea here is to allow the very diverse scientific community to utilize this across all the applications and tools that they currently use. whether it be their own code, whether it be ArcGIS, whether it be whatever else. And so what we've designed the system around is specifically to emphasize a programmable interface. That's what an API is. And it's just basically a way for programs to talk to it. So a program can interface with this, say, I have this data, transform it to this data, and it does it and returns the data to you. And to do that in a programmatic way, so you can loop through a directory and do it to an entire collection or whatever else you want to do inside of a program, and other tools to potentially leverage it as well. So again, supporting diverse usage. So again, the scientific community, all the different domains out there, they have lots of different client applications that they prefer, lots of different languages they prefer. Python's popular in astronomy, R's popular in ecology, MATLAB's popular in computer science, and so forth. So being able to support any of those things is important to do for this kind of thing. And then a host of other features common to, I would say, many scientific needs, scalability, being able to do this on large data sets or data sets with a large number of files to them. Being able to do this in a distributed manner so that you can run it at one university and another university and another library and so forth. Lots of different pieces. The way it did things for a particular transformation. Other aspects like file validation, make sure I get what I thought I was getting. Information loss tracking, so I can kind of estimate these tools are better than these other tools. And lastly, I would say tool preservation and publication is a key aspect as well. So basically capturing these tools that are being developed within the scientific community to do specific things for their project that other people could potentially use as well. And all this is open source software. So the Brown Dog API, just briefly, so the main interface, again, it's a REST interface, a REST programmable interface. So basically that means in URL form and HTTP, you basically issue these commands to it at the lowest level and give it a data set, get something back, some transformed version of that. And so you go here to bdapi.ncsa.illinois.edu. These are the things you can do from authorization stuff, basic housekeeping kind of things, to the conversions where you specify inputs and outputs, extractions where you basically specify individual extractors, a whole suites of extractors, and provenance so you can tell what's going on where. And so this is at the lowest level. And so for some people that's fine, for others or people that's not fine, and that's where the client applications come into play. But before I get into the clients, I just want to kind of throw out this analogy. So in terms of how this fits into either the data infrastructure world of science or within the internet of today kind of thing, it's kind of analogous to a DNS. So a DNS is a domain name service, which if it was to ever go away, you would notice immediately. So you couldn't go to google.com because it wouldn't be able to translate. What it does is basically translates that to IP addresses. Is what machines need to know to route your traffic. Brown Dog basically kind of analogous to that. It doesn't transform something as simple as that. It transforms basically anything. And so the key here is data, file formats, or extracting these derived products. Either way, going with that analogy, again, is the idea of a distributed nature. Both of these things are trying to emphasize basically that they're not at one location, but kind of made up of a bunch of different pieces that talk to each other to do this service. I won't get into that too much today, but that's a key aspect of this as well. And so how this fits into things is basically three major parts. One is into other data cyber infrastructure components that are being built out there, and I'll touch on those. Second is with regards to the users, you guys, to facilitating your data wrangling needs. And lastly, in terms of, again, publishing these data transformation tools so that other people can leverage them. So in terms of the data management landscape, these are just some of those. These are the data infrastructure building blocks in the data nets, the NSF's data portfolio, basically, at the moment. And there's a number of these things that deal with aspects. I put XC down here as the computational data storage resources that NSF provides. And then on top of it, things that kind of extract away the storage layer, things that provide data sources for communities like astronomy and other communities, ecology and earth science, so forth. And then service kind of stuff on top of it, curation tools. Brown Dog here is basically a transformation service. Geospatial analysis, high performance tools for image analysis, and a storage broker for cloud resources and things like that. And these pilot projects which kind of integrate all these things together in terms of a data infrastructure on top of that. So the idea with Brown Dog is basically servicing all these things, not just those building blocks, but everything that has been built in the scientific community to date. Things like iRods and Dataverse and DSpace, which are curation tools for preserving data and sharing data and so forth. And allowing them to build on top of it to kind of offload the transformation part. So they don't have to worry about it. They can also leverage what everybody else is doing as well. So as an example of that, one of these is PECAN. This is an ecological workflow system for basically connecting a bunch of models in the ecological community and doing analysis on them to kind of see which ones are sensitive to which data inputs, trying to do a prediction over time of carbon storage over large periods of time, say millennia, and so forth. And so basically it has a lot of transformations it has to deal with. It has to convert from all those different models have different input formats. It takes in data sources from a variety of places, and each of those are in different format. So basically it has to transform the data sources to the model formats, which is a lot. And so what we've been working with them to do is kind of offloading what their transformation needs are to Brown Dog. So they've added this little checkbox here to their interface. This is their interface where you basically select a model, select a location, run it. And so when they use Brown Dog here, basically it offloads the data transformation so they can just worry about what comes after that. So that's one example there. Another thing we've done kind of to highlight one of the possibilities that can be done when you start thinking this way of separating out data wrangling stuff from the science stuff is providing resources for not just your project but other projects, in this case for the ecological modelers themselves. So the people that built those models are not all part of PECAN. For example, Ed is out of Harvard, and there's other models out of Europe and so forth, 30 or so different models. And they all could basically leverage these transformations they built for this tool independently of that tool. And so one use case we did here is basically building a kind of a data products platform based on those transformations for the ecological community, those modelers, in a language that those modelers are very familiar with, R. And so using Shiny, which is kind of a way of doing interfaces in R, a couple pages of code with custom calls to Brown Dog, here we were able to put together this little landing site where basically you can select a location and select a format. You know, this example here is for Ed. You can't see it on the screen, but for the ecological demography model, and then download the data. This is not an actual data product produced by anybody. In this case, we're selecting the Meriflux data source. Meriflux does not produce this data product. It kind of looks this way because this transformation service in the middle there is doing this transformation to make this data product. And so that's a key thing. So lots of these scientific endeavors produce data products, but there's always more that can be done for different users. LSST being an example, they produce data products. The Modus satellite produces data products, but there's always more, and there's more than the products they can produce, and this is kind of a way of handling that. DataNet Seed is basically one of those building blocks that deals with curation. So think of it like a smart Dropbox where you can assign metadata tags socially, or there's also this possibility to do auto curation, where this is actually, we leverage this technology in Brown Dog to do the extractions. Basically, a file is uploaded, stuff gets spit out like metadata. And so we can, basically the transformations we build within Brown Dog are leverageable directly back into this DataNet Seed effort in this Dropbox-like environment called Clouder. And so this example here, basically there's a Google map kind of thing in the middle, and basically somebody's uploaded some LiDAR data. And what's happened here is flood basins have been extracted and overlaid on top of the LiDAR data. This is one of the extractions that occurred for LiDAR data. And somebody also uploaded some digitized maps from the 18th century. And from that, these rivers locations were extracted from that and also overlaid on the map. And so you can see how these change over time and how these relate to the flood basins here. And this was for one of our hydrology use cases. But again, highlighting the example of how this is basically being leveraged in another data infrastructure components. And that's the idea. So like going along again with that DNS analogy is, you know, browsers use it, operating systems use it, lots of different things use the DNS. Lots of different things will use this DTS, this data transformation service. Scientific workflow systems are another popular thing as well that are being built these days. Basically a kind of a graphical, reproducible way of coordinating what happens as you use software and data in science. So little components that you connect together. And so this is one of many of the scientific workflow systems out there, but basically being able to use these kind of transformations there as well. So then one is the API directly, which I'll touch on a little bit later, but do a number of client applications that we kind of bootstrapped as well. So ideally, the community will start building these client applications themselves, but to kind of help that along, we built a number of them already. And so the first one I'll show you is the Windows client. So basically, like Dropbox, when you install it, there's a Dropbox client natively for Windows or for other operating systems. And so we have one for Brown Dog. So basically, you can go to your file manager, right-click on a file, and access these capabilities, such as converting to a different format, right-clicking on a folder of files, and and basically indexing it. So basically what it does then is it runs all the extractions on it can. It has a little database where, and there's a search capability here too, it basically goes through that and says, oh, find me all the things with green index greater than X. And so to give you images related to that and so forth. And so those kind of things. So as an example of one of our hydrology use cases, they want to do this analysis on LiDAR data. So there's a GeoTIFF file. And so basically to do the analysis they want, it has to be in this band interleave format build. To do that, so the first thing the person has to do is convert it to that. So he right clicks on it, converts it to this build format. And then once they do that, it basically gets added to their desktop there. And the next step is to do the analysis, which is part of the extraction suite. So basically they right click and do extraction. And basically all the what gets sent back to them is the JSON file with stuff that an application can then use to get the data that was spit out, but also all the derived products that were generated as well as a folder that was generated for them. And so as part of that is lots of different things. And so some of these are some plots of a chai analysis kind of thing that was done there as well. So they can do whatever they want with that or leave it as that and just sift through the information there in kind of a raw format. So that's one example. Command line interface is another. So this is an example here where an old photo CD image that I can't open. So I'm converting it to a PNG and then running it and then typing it into the command line again. And then extracting everything I can from it. So in this case, it's spitting out all the metadata that it can get from it, things that it detects, metadata like geolocation and so forth. And again, this is the JSON form that an application would build upon. One of the more user-friendly interfaces we're worked on too that's pretty portable in terms of web browsers and for users is a Bookmarklet. And so what that is basically a piece of JavaScript that's contained inside of a bookmark. I don't know if you've encountered these before, but basically you bookmark this thing, so you can drag and drop it to your bookmarks. And then you go to some random web page and you click on that bookmark and it executes some JavaScript on there for you. And so what this does is if you go to some page with links on it, this is a simple page, but any page with links on it, it adds these menus to it so that you can right click on it. It's kind of hard to see on the screen here, but it puts this menu there for different formats you can then download the data as. And so you can download the data in different formats. And here's an example in Dropbox doing this as well. Or you can basically go to a web page and index its entire contents. So for example, all the images and links and pieces of data, objects that are on this web page or its children pages, press Control F and it basically brings up this little window here where it says create an index for the data where it basically runs the extractions and all the files there. And then you can do the search kind of mechanism as I showed you with the Windows plugin again and find the stuff that you actually want and download that. Beyond that, there's more scientific specific tools as well. Again, the scientific community has their suite of tools that they use within their community. In the hydrology community, for example, there's a lot of geospatial software that's used, and one of the big ones is ArcGIS. And so basically, we can add plugins to that. So in this example here, there's a plugin for Brown Dog, which takes LiDAR data and does stuff, an extraction on it for trees. Find all the trees in the LiDAR data. So here's an example where it kind of put boundaries around the LiDAR data for trees. You can zoom in on that there and things like that. So basically different kinds of extractions natively in ArcGIS. And alternatives to ArcGIS, which is a commercial piece of software. So like QGIS, which is the open source alternative. Same kind of thing here. So running the exact same tools. In this case, the same thing, the tree delineation, and do the same kind of thing in an open source environment. Excel. This is a very popular piece of software across any scientific community as far as we've encountered with our support of them. And so that was one of the key ones we wanted to make sure we can interface with. And so in this example here, this is for our civil engineering use case. Basically, they record the paths of people walking through cities as coordinates, latitude, longitude, and a spreadsheet. It's actually spit out of a sensor that they have the people carry. And so we could create plugins built on this API for Brown Dog to do stuff. In this case, they wanted the green index of that route, how much foliage was encountered by the pedestrian as they walk through that particular landscape. And so basically they can run that extractor on some subset of cells there, and what it does is basically generates a new sheet at the bottom here with that green index information that was extracted out of that for them. So another example of a kind of their client interface. Again, going with that DNS analogy, lots of different things building on top of this thing. One of the main interfaces we're trying to highlight is when people sign up is kind of the one that kind of highlights all the possibilities. And so this next one I want to show you is called BD Fiddle. It's based off of this idea for web developers called JavaScript Fiddle, which it kind of lets them navigate JavaScript, CSS, and so forth for web developers. But in the case of Brown Dog, navigating these transformations. And so what you can do here is when you go here is you can try out the transformations. You can upload a file, select an output format, or select some sort of suite of extractions, and then get the output here. But not just that, but get the code snippets that you can then copy and paste into your code, whatever it might be. So we have examples for just running it in a terminal or Python. We have a wrapper library, which kind of simplifies the Python. We also show you what it would take in the native Python using like the request package to interface with the REST API and so forth. It's a lot bigger, a little bit longer. Code in R, again, where we have an R library to simplify things. Code in MATLAB, where we also have a library to simplify things. And even JavaScript, so you can do this in a web page, execute these kind of transformations and so forth. And so you can basically take these code snippets and do stuff like run them in a Jupyter Notebook. You can actually download the Jupyter Notebook. The link's not in here, but in the new version of BD Fiddle, there's a link right under it where you can open up a Jupyter Notebook and run the code right from there. Or copy and paste it into your code. This is an example of one of our use cases, again, in green infrastructure. And so this was his code beforehand. It's basically identifying green infrastructure types and images. So I think what he's identifying here is bioswales and satellite images. And so he wrote this code. Basically, he wrote the extractor to do this. This code comes to about 273 lines of Python. It includes some packages like OpenCV, which is not the funnest thing to install in a system. And so to rerun this stuff, you'd have to have all that there. And so the idea here is kind of highlight, what about the next person? So the person who could leverage this green GI type identification in terms of using it again, not having to rewrite this, not having to reinvent the wheel, not having to install any of this stuff. So as kind of an example of what that might look like, we rewrote his code using Brown Dog with his extractor as an extractor, basically. His code is an extractor. And so that kind of takes it down, significantly. So the next person utilizing his GI type identification, basically this one page of code, from 273 lines to 55 lines, they don't have to install anything special like OpenCV. It's much simpler to run. And this is without the little wrapper library, too. If you include that as well, it takes down a few more lines to only 47 lines of code. So significantly reduced does the exact same thing. It basically goes through a folder of images and basically pops them up, drawing these bounding boxes and recording subsections that have these GI types, bioswales in this case. So the idea is that, basically leveraging somebody else's transformation tool and simplifying yours much by a lot going forward. Which kind of brings us to the last part, which is about publishing data transformation tools. So for example, for that code written by Ankit Rai, so that he can publish that code. And this is kind of a movement that's happening these days with regards to not just preserving data, but preserving software and making it first-class citizens in terms of the scientific world, in terms of your CV. You get credit for publications. Publications, papers are not enough to reproduce your results anymore, your science. The data and software is critical too. So there's this growing movement towards making those first-class citizens and being able to cite and get credit for those kind of things as well. So data is being done by a number of curation technologies that was part of that infrastructure landscape. Software is a newer thing that's starting to come into play as well. Things like Zenodo kind of emphasize that as well. And so here it's in terms of transformation tools is kind of like an app store where people like Ankit can put his GI type identification code. And then what we've done is trying to really simplify what it takes to do that, to add it to this transformation service, really minimize it. And make it available for others to use, and we'll basically track it, how often it's used, and give it back to him so that he can get kind of credit for that. At some point, we'll provide DOIs too, so that other people can cite that code when they utilize it. And so basically preserving those kind of capabilities for other people to leverage as well. So we're moving towards, this project, our beta release early next year. And so as part of that, we'll have a number of transformations we've built with our 3 use cases. And so on the biology side of things, a lot of them take the form of these ecological models, being able to convert to the formats they need or the data sources they utilize to different formats. As well as a few others. This plant CV, the one here, for example, to extract traits from images of plants and so forth. Our civil engineering use cases and green infrastructure, so a number of the transformations there with regard to like GI type identification, social media stuff like human preference score extractions and so forth. Hydrology, lots of LiDAR data type stuff here in terms of finding rivers or characteristics on rivers and flood basins and so forth, and things like that. And then a bunch of other project-supported transformations we've kind of accumulated over the years working with the scientific community. So stuff in social science, for example, work with videos, cinematography, extracting shots, finding similar shots, information for that kind of stuff. finding images with certain characteristics. There's counting the people in them, who's talking to who, stuff like that. With regards to genomics and medicine, stuff like extracting things in biopsy images, finding where they're at, or classifying features. And general stuff as well. So basically document conversions, document extractions, extracting faces and things like that that anybody could potentially use as well. So in all, about 82 different transformations that'll be part of that initial suite. But the idea is to kind of grow that over time. Just kind of bootstrap the process. And so we'll have basically as part of the sign-up process, you'll get access to PD Fiddle, all these clients, a sample page with a bunch of data that you can try stuff out on, and kind of move on from there. And ideally, over time, working with the community to get more tools added to the system. So in a nutshell, I wasn't gonna get into the underlying technology that's utilized in Brown Dog, but there's a number of pieces there to kind of do this, specifically towards utilizing a large number of tools and simplifying the process of adding new tools. But I'll stop there. This is kind of the high-level picture in terms of what it is, what it does, and how others can potentially use it in the scientific world. So that's it. I'll stop there and take any questions that happen.